All right, guys, today we're going to talk about conditional statements and biconditional statements. So we do a lot of work with P's and Q's. So at this point, you need to take out some paper so that you can write down the examples that we go over today. These typed notes are online so that you may print them out if you like and follow along. Do some highlighting, filling in the blanks as we go. Completely your option, okay? So a conditional statement is if P happens, then Q will happen. All right, so before we jump into these, let's define what P and Q stand for. P means the hypothesis, Q is the conclusion. So if you think back to English class, they would tell you to underline the P, your hypothesis with one line, your conclusion with two lines. In math, we use an arrow. If P happens, then Q happens. Those are conditional statements. Now we can take those conditional statements and we can make it what they call a converse. So notice I've highlighted over here in pink. That simply means we are going to flip our P's and Q's. Therefore, if Q happens, then P will happen. And we illustrate this by Q arrow to P. So notice from the conditional, the only thing we do for a converse is flip. Inverse. All right, so for an inverse, it's going to negate. This is a new fancy word for not. If not P, then not Q. So to illustrate that, we use this mark right here in front of our P, which illustrates an inverse. That is to negate P, arrow to negate Q. So not P, then not Q. And I'm going to give some examples of each of these going forward. And then we have what they call contrapositive. Now, guys, what we're going to do is we're going to take our conditional statement and then we're going to flip and negate. Contrapositive. If not Q, then not P. So notice I flipped my P's and Q's and then I negated both by putting the not in front of. So negate Q to negate P. Here's an example of this. We call it a truth statement when we are dealing with conditional statements. Truth value is true in all situations except when the hypothesis is true and the conclusion is false. All right, so you're probably thinking this is a math class and we have a whole lot of words in here. I get it, guys. It can be a little confusing, so let's go through what a truth value may look like. So here's an example. So my hypothesis is if you make an A, the conclusion will be I will buy you a car. So my P, if you make an A, I will buy you a car. So let's talk about some truth values. So here we are, we're going from P to Q. The first one says you made an A, then I bought a car. Well, guys, that's true. If you make an A, then I will buy you a car. You made an A, but I did not buy you the car. So guys, that's false because what we're saying is if you make an A, I will get a car. I made an A, but I didn't get the car. So truth value is true in all situations except when hypothesis is true, conclusion is false. So if everything works and lines out, if P is true, Q is true, our truth value is true. But if the conclusion is false in this situation, it is false because I was supposed to get a car and I did not. So therefore, it is a false statement. You did not make an A, but I bought the car anyway. You did not make an A, but I bought the car anyway. All right, so every year students are like, wait. I thought I was supposed to make an A and get a car. All right, so go back up to truth value. It's true in all situations except when the hypothesis is true and the conclusion is false. It's true in all situations except when when the P is true and the Q is false. All right, well, look right here, guys. The P is false, but the Q is true. So it makes it a true statement. It goes against everything we want it to be. In our mind, that should be false because we didn't make an A. But we got a car anyway? To me, that sounds like a win. But, so, truth value says the only way that that guy is false is if this is true and this is false. So because of that, this is a true statement. If you did not make an A, then I did not buy the car. That's true. If you did not make an A, then I did not buy the car. A counterexample would be to make the if true and then the then false. Counterexample, I don't really like to use a counterexample right here. I will use one when we're dealing with angles because I feel like that's a little bit more relatable for us because that's what we're coming off of, our angles. All right, so at this point, what I would want you to do is to stop your video and write down this example. Write the converse, the inverse, and contrapositive of the following. State if it's true or false, and if it's false, give me a counterexample. So if we were sitting in class, I would say, all right, guys, here's our first example. Measure of angle A equals 30. Then angle A is acute. All right, so we're going to have to think back to when we identified angles: acute, obtuse, right, supplemental, complementary. So think back to that. Again, stop the video. Make sure you write this down. This would be our first example. If you've printed these notes, then it should be on your next page that you printed. All right, so let me show you what that would look like. We're going to take this statement and let's identify some pieces. If the measure of angle A is 30, that's my P, then angle A is acute. That's my Q. So we're going to go back to the very first slide when we talked about the three types of conditional statements: converse, inverse, and contrapositive. All right, so the first one that we are going to write is the converse. And guys, if you look back, all we do is flip the Q and P. So if angle A is acute, then angle A is 30. If angle A is acute, then the measure of angle A is 30. Now guys, this is going to be a false statement. And I gave a counter example. So I'm going to label that guy. I'm not sure why I didn't on my notes. But this would be my counter example. A counter example is proving why this statement is false. Because guys, here's an acute angle. We can see that because he's obviously less than an L, right? He's an acute angle and he's 19 degrees. So I'm proving that an angle can be acute and not be 30. So here's my counter example. That's why this conditional statement is false. So converse, take your P's and Q's and flip it. Inverse, all right, here's the wording. We're going to negate P to negate Q. Negate is that fancy word that means not. So go back up to your conditional. The order doesn't change. All we're going to do is put in the word not. If the measure of angle A, and notice how I put the slash in the equal sign, which means it does not equal 30. If the measure of angle A does not equal 30, then angle A is not acute. All right, another counter example. He's not 30, but he is acute. That's why he's false. I have proven that you can have an acute angle that's not 30. This guy is 25 degrees. So we've done the converse, we've done the inverse. Now guys, the next one is contrapositive. Remember, you're going to flip it. So go back up to your conditional, you're going to flip it and negate. So I've given you the notation for that right here. We flip the P's and Q's and then we're going to negate. If angle A is not acute, then angle A is not 30. Well, guys, that's true, because if he's not acute, then he has to be greater than 90 to be obtuse. So therefore, he cannot be 30 degrees. So that would be a true conditional statement. That would be the first example that we would do in class together in our notes. So now I'm going to show you the second example. We're going to do the exact same thing. Write the converse, inverse, contrapositive of the following. If it's false, give a counterexample. So here would be example number 2 if we were sitting in class taking notes. If two angles are vertical, then they are congruent. Remember, this is our notation for congruency. So at this moment, stop the video, write down this example, and then give me your 3 sentences: converse, inverse, contrapositive. Converse, inverse, and contrapositive. So again, pause your video. When you get these written, push play again. So here's our conditional. If two angles are vertical, then they are congruent. So think back when we identified angles, we talked about vertical being congruent, which means that their measures are equal. All right, so the first one we're going to do is the converse. Converse. All a converse does is flip the conditional statement. So Q to P, Q to P. If they are congruent, then they are vertical. If they are congruent, then they are vertical. And guys, that's going to be a false statement. Let me show you why. We could draw something like this. This guy could be 45 and this guy could be 45. They're congruent, but they are not vertical angles. They are adjacent angles whose sum equals 90. All right, then we have inverse. So go back to your conditional, and the only thing we're going to do now is to negate. Fancy word for not. Not P, not Q. If two angles are not vertical, then they are not congruent. Well, that would be false for the same reason I just showed. These guys are not vertical, but they are congruent. So I'm just going to say refer to that guy. You can use the exact same example. And then your last one would be contrapositive. Guys, go back to your conditional, flip it, and put the fancy word negate. Not Q to not P. If two angles are not congruent, then they are not vertical. That is true because all vertical angles are congruent. So if they're not congruent, then they can't be a vertical because all verticals are congruent. All right, so those would be the 2 examples that we would work together in class, and your homework on page 95 will practice that for you. But there is one last slide I would like to show. Biconditionals, we're going to do a little bit of work with biconditionals, but not too much. So P is true if and only if Q. So P can only happen if Q happens. So all definitions are biconditional. And what that means is, guys, I get it, these are really big fancy words, okay? All definitions are biconditional. This is an example of that. Two angles are supplementary if and only if their sum is 180. You can read it backwards. If their sum is 180, their sum is 180 if and only if those 2 angles are supplementary. So that's a definition of a supplemental angle. Supplementary angles, their sum is equal to 180, and that only happens, they're only supplementary if and only if their sum is 180. So that's just where you can read it both ways, and it has to be true on both ways. If this happens, only if this happens. This happens only if this happens. So don't fret too much about biconditionals because all your definitions are biconditionals. And we'll do a little bit of work with those as we go forward. So your homework on page 95 will help hone in on these skills that we've talked about today with conditional statements.